Here in lesson 35-1, we're going to be solving a system graphically. We will split this lesson into 3 sections: questions 1 to 4, questions 5 and 6, and question 7. Professor Hurst is studying different types of bacteria in order to determine new ways to prevent their population overgrowth. Each bacterium in the first culture that she examined divides to produce another bacterium once each minute. In the second culture, she observes that the number of bacteria increases by 10 each second. Each population began with 10 bacteria. Complete the table for the population of each bacteria sample. 0 minutes elapsed. Of population A, we have 10 in sample A. What happened after 1 minute? Each one divided into 2, okay? Because it says divides to produce another bacterium once each minute. So after 1 minute, each one of these 10 have now split themselves and created another one. So that makes us have how many? 20. After 1 minute's time, these 20 bacteria now divide themselves and create 40. After another minute's time, the 40 bacteria that we have now divided to create 80. After 4 minutes time, how much bacteria should we have? 160. And after 5 minutes time, we do indeed have 320. Let's talk about population sample B. This says, in the second culture, she observes that the number of bacteria increases by 10 each second. Each second. How many seconds are in a minute? 60. So that means that it increases by 10 60 times. 60 seconds equals 1 minute. So it is increased by 10. Increased by 10 60 times. So what is 10 times 60 in essence? 600. So in that 1 minute time, this bacteria has increased by 600. So that makes it 610. And in another minute's time, we have increased by another 600. So that makes it 1,210. And in another minute's time, we have now increased to 1,810. And another minute's time, we have increased to 2,410. And in that 5th minute that the chart went to, it is now going to be 3010. All right. Describe the type of function that would best model each population. Sample A. Is sample A linear, exponential, quadratic? I'm thinking exponential. It's doubling every time. We started with 10, we went to 20. 20 to 40, 40 to 80. It's a multiplication of 2 each time. All right, let's talk about sample B then. Sample B went 10, 610, 1210, 1810, 2410, 3010. This would be linear. Very good. All right, we're moving over to 3. Write a function, a of t, to model the number of bacteria present in sample A after t minutes. Well, first thing we have to ask ourselves, what did we start with? We started with 10. What happened each time, each minute? We multiplied by 2. So we would raise this 2 to the t power. So this would be 10 times 2 to the t exponent. All right, sample B. What happened to B every minute? It increased by 600 every minute, right? So we have an increase of 600 for every minute. And where was its starting value? It also started at 10. Go ahead and take a moment to write down questions 3 and 4's answers. And then we're going to get a debriefing question on the next slide. And then we'll move to questions 5 and 6.